Data models. Data models is relatively simple representation, usually graphical, of more complex real-world data structure. It represents data structure and their characteristic, relations, constraint, transformation, and other construct. So, yung data models po is define how data is connected to each other and how they are processed and stored inside the system. And the importance of the data model is can facilitate interaction among the designer, the application programmer, and the end user. And also, data modeling cannot be overstated. Data constitute the most basic information units employed by a system. Applications are created to manage data and to help transform data into information. Why should we do it? To gather end user different views and needs, and also it organizes various data for a user. We build data models so that we can better understand the system that we are developing. So, yung data models po is nakakatulong siya for us to visualize the system as it is or as we want it to be. Data models permit us to specify the structure or behavior of a system. Models give us templates that guide us in constructing a system. What are the basic building blocks of all data models? The basic building blocks of all data models are entities, attributes, relationship, and constraint. An entity is anything such as a person, place, things, or event, about which data are to be collected and stored. Entities are represented by a rectangle box containing the entity name in it. Attribute. Attributes is the set of characteristics representing an entity. It is represented by a leaf symbol with the attribute name on it. For example po is a student entity. It will be described attributes such as a student last name, student first name, student phone number, and student address. The attributes are the equivalent of field in file system. Next one is relationship. It describes the association between two or more entities. A data models use three types of relationship. One-to-many. For example is a painter creates many different paintings, but each of them is painted by only one painter. So that is one-to-many relationship. Many-to-many relationship naman po is a student can take many class and each class can be taken by many students. So that is many-to-many relationship. Last is one-to-one relationship. One-to-one relationship naman po ay one student can take one class at a time. So that is one-to-one relationship. Next is constraint. Constraint will be the restriction which should be placed on the data. It also ensures the data integrity. Business rule is the most important process of the data modeling or designing a database, because most of the relationship we are going to create between entities will be generated from the business rules. It can be brief, precise, and also an ambiguous description of a policy, procedure, or principle. Like we have a university, so the university policy said that the student can take only one class at a time. Or in a banking institution, which said that the many customer can open one or many accounts. So we create and also enforce action within the organization environment. Business will again create and also enforce action within the organization environment, and also business rule will establish entity, relationship, and constraint. So how we discover business rules? The source of business rule can be company manager. They may come up with the policy of the organization, or policymakers or department managers. They may come up with their own standard procedure of doing in business. Or written documentation, and also direct interview with the end user based on how end user use the system when they come up or how they do their business operation. So, reasons for identifying and documented business through one is to standardize the company's views of the data standardization. Then also we can able to facilitate communications between the user and the designer. As we said earlier, the business rule is the core way of getting the type of entity relationship, and also assist designer to understand their nature, their role, and the scope of the data and business process. Develop appropriate relationship participation rules and constraint, and also create an accurate data model. Business rules normally set the stage for the proper identification of entities, attributes, relationship, and constraint. And also when we are designing our database system, always we use the nouns to represent the entity such as a student or employee. Then the verb will translate into action. Among relationship and entities, such as a student can take one class or employee assigned in one department, so we can see that the relationship will be verb and the entities is always noun. So to properly identify the type of relationship, you should consider that relationship are bidirectional. So a general rule through no to properly identify the relationship type, you should ask two questions. So for example po, you can access the relationship between the student and the class. In the first question, in how many class can one student enroll? So, di ba? Many class. Second question is, how many students can enroll in one class? So many students. So therefore, the relationship between the student and the class is many to many relationship. Hierarchical model structure was developed by IBM in 1960. Hierarchical models are still widely used, especially in applications that require very high performance and availability, such as banking and telecommunications. Hierarchical models only have one parent or root and the several children. Hierarchical model data is organized into a tree-like structure. This structure is simple but inflexible because the relationship is confined to a one-to-many relationship. And also it contains segments. Segments are equivalent of a file system record type, and we can show it to a set of one-to-many relationship. The advantage of hierarchical model is due to separation of tables from physical storage structure, information can be easily added or deleted without affecting the entirety of the database. The most major programming languages offer functionality for reading tree-structured database, and also it is of use, and the one-to-many organization of data makes traversing the database simple and fast, which is ideal for use cases such as website, drop-down menus, or computer folders in systems like Microsoft Windows OS. The major disadvantage of hierarchical model is their inflexible nature. The one-to-many structure is not ideal for complex structure, as it cannot describe relationship in which each child node have or has multiple parent nodes. Also, the tree-like organization of data requires top-to-bottom sequential searching, which is time-consuming and requires repetitive storage of data in multiple different entities, which can be redundant. A network model normally created to represent complex data relationship effectively here is going to improve the database performance and impose a database standards. And also, This is an extension of the hierarchical model. In this model, data is organized more like a graph and are allowed to have more than one parent node. In this database model, data is more related as more relationships are established. In this database model, also as the data is more related, hence accessing the data is also easier and fast. The database model was used to map many-to-many relationships. This was most widely used database model before relational model was introduced. Codicil is a conference data system languages. Was a consortium formed in 1959 to guide the development of standard programming language that could be used on many computers. The DBTG or Database Task Group appointed by the Conference on Data System and Languages, Codicil. The DBTG recognized the need for two-level approach with the system view, code schema, and the user view, code subschema. So schema is a conceptual organization of the entire database viewed by database administrator. Subschema is seen by the application programs that actually produce the desired information from the data contained within the database. Data management language defines the environment in which data can be managed. Schema data definition language enable database administrator to define schema components. Subschema data definition language allow application programs define database components that will be used. The network model has ability to manage more relationship types, like one-to-one relationship, many-to-many relationship. Next is a network model that is designed as a flexible approach to representing objects and their relationship. A unique feature of a network model is a schema, which is viewed as a graph where relationship types are arcs and object types are nodes. Next is network model. Each child called member can have more than one parent called owner to generate more complex many-to-many relationship. The disadvantage of the network model. Network model is much more complicated than hierarchical model. As such, it is difficult to handle and maintain. Although the network model is more flexible than hierarchical model, it still has flexibility problems. Not all relations can handle by assigning them in the form of owners and members. The structure of network model is quite complicated, so the programmer has to understand it well in order to implement or modifying it.
Relational model. The relational model was first introduced in 1970 by an IBM researcher called Edgar F. Codd. Codd based the operations for the relational model on a branch of mathematics called relational algebra. At the time, the relational model was considered impractical as computer didn't possess the necessary power required to process a relational database. In the 1980s, the relational model gained widespread popularity due to the availability of greater computer power for considerably lower costs. As the cost of powerful microcomputers fell, user-friendly relational database management systems such as Oracle, Ingress, and Paradox were developed to run on them. It is also called Relational Database Management System or RDBMS. Matrix containing a series of row column. of row or column intersections. In relational database model, a table is a collection of data elements organized in terms of rows and columns. Table is also considered as a convenient representation of relations. Each table has one or more columns, and each column is assigned a specific data type, such as an integer number, a sequence of characters for text, or a date. Relational diagram. Representation of a relational database entities and relationship between those entities. So this is basically a model of a possible database implementation. In short, an ERD is an abstract concept of our database, or speaks in entities and attributes, an entity model. A relational model defines formats and relations in a way a database could understand a data model. Relational table stores a collection of related entities resembles a file. Table has two properties, rows and columns. Rows represents record and columns represents attributes. Relational table is purely logical structure. So guys, when you use this, you need to analyze carefully and extract the components based on the business rules given. So this is the sample of relational model. Now guys, you can visualize a relational database, a collection of those tables. And the table is comprised of row and columns. So, ang bawat row po ay tinatawag ding tuple. It represents instances of an entity. In other words, record. Example, the entity is the agent. So, the table will be the entity. And the rows in the table are the records of the agent. The attributes naman po are the agent code, agent last name, agent first name, agent initial, agent area code, and agent phone. So this will be the columns. This attribute domain defines the valid values for the columns. The placement of each row and column are their orders in relation to each other are no consequence in databases definition or identity. Each row should have a unique combination of values and its attributes compared to other rows in the table. So as you can see, there has a link through, and this attribute is the agent code. Also, this called foreign key. The agent code and a customer code are called primary key for each table. Foreign key is a referential integrity. Ito naman po ay in charge to make sure na yung links and connections ng tables are valid. It forms a relationship by placing a primary from one table to another table. Usually, sila po yung primary key in other table na mag-e-exist din sa kabilang table to denote to my relationship in two tables. So, the primary key naman po ay entity integrity. This is unique attribute na ina-identify in the diagrams. Relational model. This is a powerful and flexible language that brought it to dominance. SQL allows the user to specify what must be done without specifying how it must be done. SQL-based relational database application involves user interface, a set of tables stored in the database, and SQL engine. Entity relationship model was introduced by Peter Chen in 1976. The ERM and its variation have been widely used in database modeling and design. system analysis and design methodologies, computer-aided software engineering tool, and repository systems. An entity relationship diagram is crucial to creating a good database design. It is used a high-level logical data model, which is useful in developing a conceptual design for databases. An entity is a real world or concepts that exist on its own. Entities are equivalent to database tables in a relational database, with each row of the table representing an instance of that entity. Connectivity labels types of relationships. Diamond connected to related entities through relationship line. So, these are the example of ERD model. And this is the combination. So, as you can see, we use the components of data model. And these are the entity, relationship, and the cardinality. Yung entity is yung painter and painting. Yung relationship is yung paints. And the cardinality is yung one-to-many. Object-oriented model modeled both data and their relationships in a single structure known as object. Object-Oriented Data Model, or OODM, is the basis for the Object-Oriented Database Management System, or OODBMS. OODM is said to be a semantic data model, object described by its factual content, like relational models entity. It also includes information about relationship facts between objects, opposite of in the rational model. Object becomes basic building block for autonomous structures. So, object-oriented modeling consists of progressively developing object representation through 3 phases. This is the analysis, design, and implementation. During the initial stages of development, the model developed is abstract because the external details of the system are the central focus. The model becomes more and more detailed as it evolves, while the central focus shifts toward understanding how the system will be constructed and how it should function. So let's go to the other models. Extended relational data models. These extended the canonical relational data model to enable the management of multimedia object. In attempt to provide a smooth paradigm shift to multimedia information system development, this enhanced the relational data model framework with techniques for modeling, storing, and manipulating multimedia data. Semantic data model. The semantic data model is a method of structuring data in order to represent it in a specific logical way. It is a conceptual data model that includes semantic information that adds a basic meaning to the data and the relationship that lie between them. So next is object or relational database management system. Is extending the query language allows for the integration of well-understood query optimization techniques. Typically, programming capabilities are embedded in the query language. This capability is not to be confused with the stored procedures that are provided by a number of relational vendors. So, this is the example table of object-oriented model or ER model. Katulad lang din ito ng naipaliwanag ko kanina dun sa painter and painting. But this time, we have attributes. So again, there has an entity, attribute, and the cardinality. The entity is the invoice, customer, and line. The attributes naman are the invoice date, invoice number, invoice ship date, and invoice total. The cardinality in invoice and in customer is one-to-many. Same lang sila ng cardinality ni invoice at ni line.
Good day po. Ako po si Lincoln Ambarcelo. And let's start off po sa database models and the internet. So this is the interconnectivity po ng ating internet sa ating database models. How the internet changed the database market. So alam naman po nating lahat na yung ating internet po is the most dominant thing po sa the digital world. So it can be linked to different kinds of stuff, and this includes our databases. And we can also seek for help on these kind of sites to be able to create databases without actually making the code. So the growth of web became the challenge because of huge amount of unstructured data. So dahil po nga sa paglawak ng scope ng ating web or ng ating internet is nagkaroon na rin po ng mas malawak or mas maraming growth ng mga datas na ina-incorporate po ng mga tao. This data po ay yung mga datas po na hindi na-filtered at nahihirapan na pong ma-structure sa ating internet. So, yung ating data model is nag-i-improve, kaya nagkakaroon po ng iba't ibang klase ng ating mga database models. Kaya po yung mga pinaliwanag ng mga nauna sa akin nag-report is hindi lang po sila yung database model. Mas marami po pong iba. Because of the shortcomings ng mga previous one, gumagawa ng mga panibagong design yung ating mga designers ng data model para mapunan yung mga pagkukulang na meron yung mga previous one. Yung mga panibago po is nagkaroon ng mga characteristics, at yun nga po yung simplicity, yung realisticity, consistency, and integrity. This three po is something na naging factors po na naisaalang-alang for us to choose the database model na gagamitin po natin all throughout the database modeling career natin. Next po is yung data models. So, dito po, kung mapapansin nyo po sa ating figure, yung figure 2.8, mapapakita po dito yung development po, yung mga nag-improve po dun sa ating data models through the years. So, first po dun sa hierarchical model and network, medyo hindi pa po maganda yung mga feedbacks dun ng mga end user. Pero dun sa may ating semantic and object-oriented saka extended relational, medyo more semantics na siya. Tapos, maganda na po yung mga feedbacks na makikita natin dun sa part na yun. Sa data models, nagkakaroon naman ng classification from a very simple is nagkaroon na siya ng different characteristics, styles, tapos design. And mapapansin natin na yung dependency is nag-differ sa bawat type ng ating data model. And yung mga most previous na data model is mas simple na lang siya i-process or mas madali na lang siya gawin. Yung ating American National Standards Institute or ANSI at yung ating Standard Planning and Requirements Committee, sila yung nag-define or nag-expound ng ating framework for data modeling. So, this is based dun sa internal saka external at conceptual na nanggaling mismo sa ating mga end user. Yung framework, sa pagkakaalam ko, is siya yung plan na nandun na yung mga ideas about dun sa data modeling. Tapos, andun na rin yung mga rules na dapat nating sundin sa ating paggawa ng ating data model. Next is yung sa degrees of abstraction. So, kung mapapansin natin sa figure na to, is yung entity relationship o yung makikita nating ER, sila yung may pinakamataas na degrees of abstraction. Dahil sila yung hindi na kailangan ng literacy dun sa hardware saka sa ating software. Next naman sa medium is yung relational model saka yung object-oriented. Kaya sila medium dahil kailangan natin ng konting dependency sa ating software at independent na tayo kahit wala na tayong literacy dun sa ating hardware. Next naman, sa pinaka-low is kailangan ng both na literacy dun sa ating hardware saka sa software. Kasi hindi mo magagawa yung network saka yung hierarchical model without actually having that knowledge dun sa ating hardware saka sa ating software. Next is yung internal model. So, sa ating internal model ay dito mapapakita yung representation ng ating database na nakita mismo ng DBMS. So, ano nga ba yung DBMS? Sila yung Database Management System. So, yung internal model natin is merong internal schema. So, yung internal schema, isa siyang low-level data model. So, napakasimple lang niya. Pero, may dependency pa rin or mababa pa rin yung ating data abstraction or mahirap pa rin siyang gawin without the literacy dun sa ating hardware saka dun sa ating software. Yan po yung ating example ng internal model. So, kung papansin nyo, sobrang simple lang niya and yun. Pero marami siyang mga dependencies. Saka yun, next na natin. Physical model naman. Sa physical model is meron tayong lowest level of abstraction. Ibig sabihin, kagaya ng internal model is dependent pa rin siya dun sa may ating software saka sa ating hardware. So, sa physical model, nagsisave tayo ng design na to sa ating mga storage medias. Yung storage medias na yun ay, halimbawa nun ay tapes saka disks. So, ayan nga, software and hardware dependent yung physical model kasi sila yung nasa pinakababa ng ating figure kanina. So, kailangan natin ng knowledge dun sa ating software saka dun sa hardware bago tayo makakreate ng physical model. So, ito yung levels of abstraction ng external, conceptual, saka internal, saka physical model. So, kung mapapansin nyo, both nung internal saka physical is, yun yung may pinaka mababang levels of data abstraction. Dito sa internal model, hardware lang independent yung internal model. Tapos, sa physical naman, dependent siya dun sa both, sa hardware saka sa software. Kasi, parang nabalik dito sa So, yan po yung figure. So, let's end this po in a summary po. So, yung data models are being affected by different needs or pangangailangan ng mga designers. So, that is why nagkaroon ng iba't ibang designs for people to choose what suits them well. Because, sabi nga ni Miss Jeremy Beren kanina, meron yung mga data models na pros saka cons or advantages and disadvantages. So, kaya we are free to choose kung ano yung data models na mas convenient para sa atin. And there's some building blocks na kailangan nating tandaan, and these are entities or yung paglalagay ng data. Tapos yung attributes or yung classification ng ating entities, relationships or yung kaugnayan ng entities sa ating other entities and attributes. And constraints po, yung mga restrictions po. Yun lang.